Trust me, this is going to be a crazy video. Like, what could possibly go wrong? Basically using the wrong equipment to fix a small problem, which is obviously the best way to solve anything, right? This device is called an XL609E1 DC to DC step-up converter module. Yes, the name alone sounds like it requires a PhD to operate. It is basically designed to increase lower input voltages to higher output voltages. So in simple terms, it takes your sad low voltage and gives it a motivational speech until it becomes something greater. And this is the reason as to why I am considering using it. Since I got into the FPV hobby, I have been using these two batteries, one to power my RC car and the other to power my FPV setup. And I am tired of having to charge two batteries just to have a 20-minute fun session with my FPV RC car. That's not a hobby anymore, that's a part-time job with unpaid overtime. So my plan is to use this 3S LiPo battery to power both the RC car and the FPV setup. Sounds efficient, right? Revolutionary even. But here is the problem, because of course there's a problem. Whenever this VTX is set to the maximum 2.5 watt setting and the battery's voltage drops below 11 volts, the video signal goes for a nap. And this is why I have been using this 4S pack to power the FPV setup, and it has never disappointed me when it comes to its performance. In my 1/8 scale RC car, it was never affected because the car was big enough to accommodate the extra weight and size. But in my current 1/10 scale RC, I have just been forcing it to work, and it's time to address this problem. I know some of you are already in the comment section screaming, this step-up converter can't support the power-hungry VTX. Relax, that is the theory side of the story. This is the let's ignore common sense and see what happens side of the story. Let's put it to the test. And to make it worse, because why not? I will first set the converter to 25.2 volts so as to trick the VTX into thinking I am using a 6S battery to power it. Yes, we are now lying to electronics. What could possibly go wrong? An hour later, I have barely managed to squeeze this device in between my two dudes, completely destroying the aesthetics from someone else's point of view. From my point of view though, this is modern art. Especially with this massive capacitor just sitting there like it pays rent. Again, was it really necessary for me to use this massive capacitor? Absolutely not. But personally, the more electronics I can cram inside this RC, the cooler it looks to me. At this point, I'm not building an RC car, I'm building a portable electronics store. Let me get back to this unnecessarily big capacitor, because clearly subtlety is not part of today's plan. First of all, I should have installed a low ESR capacitor, but me being me, why use the correct component when I can use the less effective one? It perfectly matches the theme of this video, questionable decisions with educational consequences. And maybe, just maybe, I'll learn why I should have done it the right way, eventually. Probably after something smokes. This device has its own capacitors, but I decided to ignore them. So my goal for adding this capacitor is for three main reasons. The first is to reduce flickering in the analog video feed, which can be easily triggered by the ESC and the motor. Basically, anything that breathes electricity in this setup. Secondly, it should help with voltage stability, which should prevent the VTX from randomly resetting, especially when throttling up the RC, because nothing says fun like your video feed rage quitting mid-run. Last but not least, my 2.5 watt VTX can pull sudden bursts of current, so the capacitor should supply short bursts instantly. In theory, that should reduce stress on my thin wiring. Yes, in theory. Do I know if these wires will hold? Absolutely not. But there's only one way to find out, and it usually involves sparks. Now this is how I have been mounting both batteries on this 1/10 scale RC car, and honestly, I'm not proud of it. This setup looks like I lost a bet. Apart from affecting my ego, this also prevents the shell of the RC from closing as intended. Additionally, it disrupts the weight distribution, causing one side of the RC to be unbalanced. So basically, my RC car handles like a shopping cart with one broken wheel. So as I had mentioned earlier, I plan to use one battery to power both the RC and the FPV setup. Just ignore this ugly makeshift connector. It looks like it was designed during a power outage, but it is only there to first test if a 3S LiPo can power this setup before I dive deeper into this project and my bad decisions. Also, this 3300 mAh is such a small fuel tank, and in this same video, I will try to build my own fuel tank with more capacity. So it's high time you make yourself a cup of coffee, maybe two, because we are about to go deep in this video. Now that the FPV setup has been on for more than 20 minutes and the step-up converter is not overheating, maybe after all this might not be such a bad idea. Which is suspicious because normally my projects start arguing with me much sooner. But I don't want to power the FPV setup from the balance leads of the battery. I need to just plug the LiPo into the RC and instantly power both the RC and the FPV setup. I know this is such a bad idea, but I can't help but try to get power from the receiver. Yes, I know, somewhere an electrical engineer just dropped their coffee. Most receivers are rated to output 5 volts to 7.4 volts, and the worst part is that they can only handle 1 ampere to 2 amperes and sometimes less. They are basically designed to power gyros, GPS, buzzers or lights, but not for a boost converter feeding a high power VTX. In other words, I'm asking a bicycle to tow a truck. Okay, let's power on this thing and see what will happen. And yes, here is the first red flag. I had set this boost converter to output 25.2 volts earlier, but it's really struggling to output anything above 5 volts. The voltage is slightly trying to go up, but it's only maxing at around 6 volts. Let me try to steer or throttle the motor and see what will happen. Just have a look at the lights, the way they are dimming. It looks like this RC is blinking "Help me" in Morse code. Probably something is about to smoke. Also, check out the fluctuation of the voltage. This setup is less stable than my life choices. Let me stop this before things get ugly. What was I even thinking? The right thing to do is to hijack the power from these wires before the current reaches the ESC. The thickness of these wires gives us the clue that the amps flowing through them are more than enough to power the boost converter with no hiccup. As you can see, even when I throttle up the motor, the voltage remains the same. So it's time to clean up the wiring. Give me a minute and I will be back with the final look, assuming nothing catches fire before then. I'm curious though, what could happen if this boost converter were to come into contact with water? Do you think it would be wise to waterproof it? Because knowing my luck, the first puddle this RC sees will immediately turn this project into a live science experiment. I realized that my wire management could use some improvement. Some improvement is a very polite way of saying it currently looks like spaghetti with trust issues. But on the bright side, this setup means I no longer need to juggle 2 separate batteries, and honestly, that alone feels like personal growth. I've even decided to remove the power switch for the RC. Yes, I know it sounds dramatic, but hear me out. My reasoning is simple. If I accidentally switch off the RC and forget to unplug the battery, the VTX could completely discharge the battery, rendering the LiPo pack useless. And nothing hurts more than realizing your expensive battery has quietly passed away while you are busy doing absolutely nothing. With the switch removed, I won't have to worry about that because the lights and the noise from the ESC's fan is loud enough to serve as reminders for me to unplug the LiPo after use. Basically, the RC now screams, "Hey genius, unplug me." Now, it's time to take this setup out for a test run to see how everything performs in action. Earlier in this video, I mentioned that I would be building my own LiPo pack with a greater capacity. I'm excited to let you know that I've already begun that process. However, testing each LiPo has proved to be quite a hectic endeavor and really deserves its own separate video for thorough coverage. Also, if I included it here, this video would be longer than my list of questionable decisions. If you are anticipating that part in this video as I had promised, I sincerely apologize and hope you'll consider subscribing, as it's on the way very soon. Think of it as a cliffhanger. I appreciate you sticking with me to the very end of this somewhat chaotic video. If you made it this far, congratulations. You are now emotionally invested in my electrical problems.